Hey, how's it going? Welcome back. So today I'm going to walk you through how to create the training data set for our object detection model that's going to be able to detect our targets on our screen for our game. So if you haven't seen the previous video, essentially what I've done is I've generated a game, which you can see most of the code here in Pygame. That's like a shooting gallery game. And what we're trying to do here is we want to train a neural network model that can detect all of our targets and then give us back that information, right? It'll tell us the locations of all the targets on the screen at any given time, right? And then with that information, what we can do is we can just write a little script that takes the outputs from our model and then just goes and clicks or shoots all the targets based on where they're being detected. So what you need to do in order to train a object detection model is there's a few things you need. You're going to need images, and then you're going to need annotations for those images. There's a few different ways you can annotate the bounding boxes of the objects you're trying to detect. What we're going to do is we're going to actually generate bounding boxes that are going to get the top left XY coordinate as well as the width of the bounding box and then the height of the bounding box. So what we have, right? So basically what we have right now currently is a screen, and then we create all of these different target objects, and then it blitz those targets onto the screen. So essentially we have access to a list of all of our targets. So we can use that and use the built-in Pygame functionality in order to get the different coordinate information. Okay, so let's go ahead and take a look. So just a kind of a quick rundown again. Here's kind of the already generated code. I'll post a link in the GitHub to the previous video's code as well as this video's code. I've kind of erased some of the game loop because we're going to kind of manipulate that and mess with that a little different, right? So let's go ahead and create the game loop again. So I'm going to actually create a running variable here. We're going to set that to 0. So essentially what we're going to want to do is we're going to generate, we don't want to use the same image, right? So we want to randomly blit these targets on the image so that we have a bunch of different images with a bunch of different target orientations so that our model can generalize and learn different things, right? So we're going to go ahead and set running equals to 0, and then while running is less than some number, right? So here I'm just going to generate 5 samples, training samples. You would obviously want to make this bigger when we actually go to train our models, but this is just kind of to show you. So, and then you can go ahead and set up the Pygame event loop, just kind of like we had before. So if we call quit, we want to set running equals like 10, right? So, okay. All right, so here what we're going to do is we're going to actually generate our targets. So before we generated our targets outside of our event loop, the reason we're going to generate our targets inside the event loop here again is because we want to, on each iteration, generate a new set of targets so that they're random. So I'm going to go ahead and call our generate groups function using the screen and then our config. So we haven't generated a config. We'll want to regenerate that config at each time step as well. So let's go ahead and do that. So if you remember from the last video, essentially I make these config files. I'm going to go ahead and just copy and paste this here in order to set up our game loop and set up our targets. So essentially what it is just a dictionary, and I have my group of large targets, medium, and small. And then the different parameters we need to pass to that is how many of those targets we want. Normally we would just hard code a number, but since we want to randomly create these different images, which you'll see here in a minute, we're going to create a random variable between 0 and whatever we want, say 5 here. Scale is how big we want that target to be. So I want it to be 15% of the screen width, and we'll give that 10 points. And then same thing follows suit for medium and small. The only difference is the smaller they get, the more points they get, and the smaller they actually are scaled to being on the screen. Okay, so now that we have our targets, so what will happen is it'll come through this loop, and then it'll randomly generate a config file, and then it'll randomly generate targets based on that config file. And then what we want to do is we want to go ahead and blit those onto the screen. So we're going to go ahead and background image, or actually here we're going to blit our background image onto the screen. And then after we've blit that on the screen, then we're going to go ahead and draw our targets onto the screen. I think I'm actually missing, yeah, here we go. So this should actually have another bracket. Okay, so yeah, so now we're just gonna go ahead and iterate through our targets. So for group in targets, group.draw on the screen. So this is kind of built in Pygame functionality. And then for group in targets, group.update. So yeah, okay, so just basically updating the targets and the target locations. Okay, so all right, now that we've kind of done that, we're gonna go ahead and skip splitting the score on the screen. We could split the score on the screen, but I don't think it really matters. We're gonna go ahead and .display .updates. We're gonna go ahead and update display. Actually, we'll split the score on the screen here. We might as well. But what I'll do is I'll just go ahead and copy and paste that. So basically, just writing the score on the screen using some just some Pygame built-in font. Okay, so then we're gonna go ahead and click. So this is just very similar from our this is exact same as what we have in our previous code. And then what we're gonna go ahead and do is create our bounding boxes and write those out. And then also, so we're gonna call create bounding boxes on our targets. So we're gonna create bounding boxes based on the targets that were randomly generated. And then what we're gonna go ahead and do is call pygame.image.savescreen to our images folder with our screenshot. And then running is gonna be just a random integer. So then it's gonna increment it appropriately, right? So what we haven't done is we haven't defined the create bounding boxes function. So let's go ahead and let's go up here and we'll go ahead and do that. So okay, create bounding boxes. Go ahead and pass targets to that. Okay, so essentially what I want to do, and you can do this in any way, right? You could create JSON files, write them out to JSON files. What I'm going to do is I'm just going to create some CSV files and write them out to that using pandas. So essentially what you're going to want to do is you're just going to want to create a list of essentially bounding boxes, and then we'll write those out to a CSV file for that particular image. So how are we going to go about doing this? Well, first what I'm going to do is I'm actually going to go ahead and create a bounding box data class. So from data classes, go ahead and import data class. And then what we're going to do is we're going to create a data class called bounding box so that it can store variables. This is similar to a name tuple. So if you're familiar with those, it's really the same kind of idea. What we're going to do is with the things we need, right? We need our left, which is going to be an integer. We need top, which is going to be an integer. And then we need height, which is going to be an integer. And we need width, which is going to be an integer. Must have some kind of syntax error going on. Let's go ahead and, yeah, it must have some kind of syntax error. That's why it keeps indenting. Okay, so let's go ahead and run this. Actually, go ahead and take a look. Just run that, see if there's something that pops up. No, it looks good. Okay. Let's go ahead and just move this up here. Might as well just kind of redefine where functions are at and pull them away from our actual game loop. Okay, so go ahead and, now that we've created this data class, it's got a bounding box data class. Now what we can do is create a list of these, right? And what's really cool, so each of these targets actually inherits from the sprite class, right? So it has these different attributes. It has this rectangle attribute, and then it also has, within the rectangle attribute, different coordinates, right? So what's really cool is we can go ahead and create our data frame equals pandas.dataframe. And then what we're going to do is create a list of bounding boxes. So we call our data class. And then we need our left coordinates. So the target dot rectangle dot left. And then what we're going to do is we're going to actually divide that by the screen width. So right now our screen width and height is set to like 1,600, right? So, but that's kind of arbitrary. So you can set that to whatever you want. And also when you go to run this in your model, you're probably going to resize the images as well anyways. So what you want to do is set that to a percentage here. So what we're doing is dividing the left, which will give us a pixel value, dividing it by the screen width, which is how many pixels there are, and it'll give us the percentage of the pixel value. So when we go ahead and resize our imagery, we can still use this information and not have to know like what the size of the input image was coming into it. Okay, so we're going to go ahead and do similar things, except we're going to go ahead and get the top, rectangle.top. and we're going to divide that by the screen height. And then we're going to go and need to get the height. So we'll go rectangle, oh, sorry, target dot rect dot, I believe this one is, yeah, okay. Height divided by target dot, oops, no, okay, divided by screen height. And then we're going to go ahead and go target dot rect dot width, and that's going to be divided by the screen width. Okay, so we've got a list here. We're not quite done making this, but okay, essentially we've got bounding boxes, right? So then this is going to be for group in targets, and then for target in group. Okay, so essentially what this is doing is, again, iterating through our list of targets that we've generated. If you don't know from the previous video, when we create this generate groups, what it does is it creates a list of groups, which each group then has potentially multiple targets in it. So we're just doing this nested for loop and using list comprehension in order to generate this. Okay, so the next thing we're going to want to do then is, now that we're created our data frame, is we're just going to write it out to a CSV. So df.toCSV, and then I'm going to take a look at what I called this. Yeah, okay, so F for, so that we can pass variables into this string. Then what we're going to go ahead and call it is, we've created a bounding boxes folder, and then we're going to go bounding box is underscore, and then again running, and then dot CSV, and then you're going to go index equals false. Okay, so that should be our create bounding boxes function. Okay, so now that we kind of generated our, basically all the functions we're going to need, right? Should be able to just go ahead and run this, and it should go ahead and generate everything that we wanted. Okay, let's take a look. Oh, didn't spell bounding box correctly. Let's go back and fix that. Let's actually go ahead and take a look at these bounding boxes. So what we're going to do in order to take a look at these things, at the top, I should have already imported matplotlib.pyplot as PLT. Another thing we're going to import is from matplotlib.patches import rectangle, because we're going to need to use rectangles in order to draw out the different bounding boxes. Okay, so what we're going to do is just df equals read CSV, and then we'll go bounding boxes, and then underscore 0.csv, and then our rectangles equal rectangle from patches. And how these work is you actually need to pass a, so I'm actually going to create a list here, a list of these. But how these work is you pass an XY coordinate to the rectangle as the initial argument, as in a tuple, and then you pass the height and then the width. So we're going to go ahead and do that. Let's go ahead and iterate through the data frame. So let's actually take a look at the data frame. Why don't we do that? Let's just df.read pd.read CSV. Go ahead and take a look at what we created for data. All right, so this one particular one has 3 bounding boxes. So you can see that these values have all been scaled appropriately. So now what we need to do is, when we read them back into rectangles before we write them onto our screen, we need to unscale them. We need to scale them back by whatever size we want our image, output image, to be. Okay, so let's go ahead and uncomment that. So we have a rectangle. So the first one, again, is going to be a tuple. So we're going to go ahead and take the left coordinate, and then the first location. We're going to multiply that by screen width. And then we're going to go ahead and grab the top, again indexing it appropriately. and multiply that by screen height. Okay, so that's the first parameter. The next parameter is going to need to be the width variable, I believe. Let's go ahead and take a look. And the final variable is going to be the height. Oh, and then now that we have that, we're going to go ahead and iterate through our data frame. Just got to spell things correctly here. All right, so now we have a list of rectangles. All right, so finally, now we can go ahead and read in our image. So I'm going to go ahead and import. I've already imported CV2, so I'm going to use OpenCV for Python to do this. And we're going to go ahead and take a look. So essentially all I'm doing here is, oh, I should probably put that fill equals false, right? Okay, so essentially this worked properly, right? We have our bounding boxes over our images, but what I need to do is go back up to our rectangle here. And in this rectangle, we're going to go ahead and pass fill equals false. And then we're going to set color equals to yellow and recreate that, rerun that. And there we have it. So we have our target images as well as our bounding boxes from our data sets properly displaying themselves on the screen. So again, just kind of like a little bit of a highlight into what we're going to be doing next is this is set to the original dimensions, right? So we've got like 600 by 1000. So that's not necessarily what you're going to want to use to feed into your network, which is again why we scaled these different our bounding box data set. Right? All right, and to kind of highlight exactly what that looks like when we're going to go ahead and rescale it. So it's essentially usually when you're running things through a neural network, you're going to want to rescale things to smaller dimensions to reduce the amount of parameters of the network and also to improve it, computational speed up and things of that nature, right? So this is a pretty big image. It's like 1000 by 600, something of that nature. So generally when you're working with CNNs, you're going to be using something in the more of the range of like 128, 256, maybe 512 by 512. So just to kind of highlight again why it's so important that we scale this data set properly, I'm just going to go ahead and show you here. So essentially I'm just going to go ahead and copy and paste the same code. Grab these rectangles as well. Except for what I'm going to do is I'm actually going to resize this. So when we feed these into our network, we're going to be doing this anyways. So resize. But when we do it, we want to make sure that our data set, our bounding box data set still lines up appropriately with our screen and with our input data, right? Because if there's inconsistencies in it, then how can you expect the model to learn anything meaningful? So I'm going to go ahead and rescale these by the new dimensions, right? So rescale that. And what I'm going to, so I'm resizing it. And right here, I'm going to recreate these variables. I'm going to set them equal to 256 and 256. Then we're going to go ahead and print that out. So same targets. I've rescaled things, but since we've set things up appropriately, even though I rescale the image, the bounding boxes are still being moved to the right direction and into the right locations, right? Because we're not going off of a specific pixel value. We're actually going off of more percentages of pixel values, and that way we can scale things appropriately. So now that we've done this and kind of created this code to make sure things are running properly, what we're going to go ahead and do, and what I'll go ahead and do before the next one, is go ahead and generate a pretty good data set, maybe a couple hundred, maybe 1,000 random samples of these, right? So that we can have a decent enough data set to actually train our object detection model so that we can actually start, instead of having to generate these bounding boxes on the fly, we're going to go ahead and use an object detection model to create these bounding boxes itself. And then from that, we're going to go ahead and use that in order to shoot the different targets that it detects. So in the next one, we'll probably dive into actually training the model. I'm going to use what's called RetinaNet for our object detection model. We're going to go through and code it up. I don't know if I've decided on PyTorch or TensorFlow. Maybe I'll do both, where we go up, code it up, and then run it in a Kaggle notebook and train it on the GPUs up there. So I hope you enjoyed it. I hope you got something good out of it, and I'll see you in the next one.